So welcome back. This lesson we're going to work with simplifying square roots. So we got to really talk a little bit about square roots. The square root is the inverse operation of squaring. So inverse operation of squaring. We talked about squaring. Squaring is when you have that exponent of 2. So that's squaring. Inverse operation is basically the backwards operation. For instance, add and subtract are referred to as inverse operations. Add and subtract are inverse operations. Reason being is 7 plus 3 is 10. If I do reverse thinking and subtract, 10 minus 3 can get me back to 7. So inverse kind of means to go backwards. So if I look at this, 25 minus 2 is 23. If I go the other direction, I can create an addition problem. 23 plus 2 is back to 25. So if I go one way, it's addition, but if I go back the other direction, that's subtraction. If I go this way, it's subtraction. If I go back the other way, it's addition. When I do that kind of thinking, I'm using what we call inverse operations. So let's get back to the squaring. Squaring means when you raise something to the power 2. So 0 squared means 0 times 0, which is 0. 1 squared means 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared is 81. 10 squared is 100. And 11 squared is 121. So if I want to take the square root of 0, it's possible if I think of this as 0 times 0, and we kind of go backwards. So I'm starting this way and ask myself, what squared gets me back to 0? And 0 squared is 0. So the square root of 0 is actually 0. The square root of 1 is 1 times 1, but so that means the square root of 1 is actually 1. So if I go backwards, the square root of 1 gets me back to 1. The square root of 4, remember that's the same thing as 2 times 2. The square root of 4 gets me back to 2. Square root of 9, square root of 9 is back to 3. Remember the square root of 9 is 3 times 3, which indeed gives me my 3. The square root of 16 is 4 times 4, which gives me 4. So the square root of 25, we have the square root of 5 times 5, which is 5. So again, notice how we work backwards. The square root is going back the other direction, getting back to that 5. So the square root of 36 gets me back to 6. So 6 times 6 is 36, so the square root of that is going to be 6. The square root of 49, well 7 times 7 is 49, so the square root of 49 is back to 7. The square root of 64, 8 times 8, which is going to give me 8. The square root of 81, 9 times 9. So the square root of 9 times 9 is 9. The square root of 100, 10 times 10. So we have 10. 11 times 11. So the square root of 121 would be 11. So these numbers here are called perfect squares. 0, 1, 4, 9, 16, 25. 36, 49, 64, 81, 100, 121. These are referred to as perfect squares. So a perfect square is basically a number multiplied by itself. In other words, it's that pair. So the square root of a perfect square is that factor itself. So notice how the square root of 36 has a pair of 6's. So the answer to that is just that 6 as itself. The square root of 49, notice how it's a pair of 7's. So the answer is simply 7. That's what this is kind of saying. So if I have a pair of 8's inside this square symbol, that answer is going to be 8. The square root of 81, notice how it has a pair of 9's in there. Therefore, that answer is going to be a 9. The square root of 100 is a pair of 10's, so that answer is going to be a 10. The square root of 121 was a pair of 11's, so the answer is going to be 11. So that's what I mean by taking the square root of a number. So what we'll do is we want to use this information to simplify some problems. So we'll look at square root of 96. We want to simplify that. So to simplify, what we want to do is find the perfect squares. In other words, we want to seek out these pairs. The best way for me to do this problem is, to make it more manageable, is actually use the prime factorization. Let's actually break that 96 down into its factors. So remember, our factors for our prime numbers were 2, 3, 5, 7, and 11. Those are my numbers that I want to use to break this 96 down. So since 96 is even, I know that 2 will go into 96 48 times. And since 48 is even, 2 will go into 48 24 times. And since 24 is even, 2 will go into 24 12 times. And since 12 is even, 2 will go into 12 6 times. And since 6 is even, 2 will go into 6 3 times. And notice now we have 3 goes into 3 one time. So what we're going to do is we're going to break this the square root of 96 down into these prime factors. That's going to be my little strategy. So 2 times 2, 2 times 2, times 2, times 3. Now what I'm doing is seeking out perfect squares, which in other words, I'm seeking out pairs. So what I want to do is pair them up. And notice how I have a pair of 2's here, and I have another pair of 2's there. What that tells me is these are perfect squares, and the answer is just that 2 itself. So what this tells me to do then is bring a 2 out, bring another 2 out, and I'm left with a 2 and a 3 on the inside. And everything is connected by multiplication. So 2 times 2 is 4, and those leftovers that stayed inside there, put those back together. That 2 times 3 gives me 6, and I end up with 4 times the square root of 6. And that's what we mean by simplifying the square root of 96. We want something like this. So let's see if we can simplify the square root of 216. Again, what I want to do is use my prime factorization as my tool. So I'm looking at this 2, 3, 5, 7, 11. So since 216 is even, 2 will go in that 108 times. 108 is even, so 2 goes to 108 54 times. 54 is even, 2 goes into 54, what's that, 27 times? And then 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into itself 1 time. So I'll break the 216 down into its prime factors. So I have 1, 2, 3 2's, and I have 1, 2, 3 3's. So what I have is 2 times 2 times 2 times 3 times 3 times 3. Now to simplify, what we want to do is seek out these pairs. So I pair them up. So I want to pair up these 2's, and I want to pair up these 2 3's. So this tells me that I can bring out a 2 and a 3. So 2 and a 3 come out. What's left is a 2 and a 3. So this pair comes out as a 2, this pair comes out as a 3, and then these 2's and 3's are left over. So what I end up with is a 6. Square root of 6 is my final answer. And that's what we mean by simplifying radicals. Square roots are what we're working with here. So stay tuned.